Hello, calculus students and general seekers of truth. Welcome to a lesson on integration by partial fractions. And in this example, we're going to talk about how to complete this particular integral. And technically, this is a calculus lesson, but what we're going to learn here is really an algebra topic that helps us with our integration with our calculus. So one of the first things that we should look at when we approach this problem is the denominator here. It turns out that this denominator can be factored, and it can be factored into x minus 6 times x plus 5 dx. Alright. Now many people who look at this problem will try to maybe do this by integration by parts, because you do have a product here in the denominator, and you can easily separate it into a product in the numerator. So you could do like 2x minus 1 over x minus 6. So, possible things you could do like 2x minus 1 over x minus 6 times 1 over x minus 5. And you can approach this possibly by using partial fractions. By integration by parts. However, there's a simpler solution to this problem, and this is where the algebra comes in. So what we're really going to do is split this. We're going to take this product here and convert it into a sum. Okay, so the idea right on the margin here is to convert a product to a sum. Okay, so we want to make this thing look something like some numerator over x minus 6 plus some other numerator over x plus 5. Okay, because when we do this addition, the LCD, the least common denominator, is going to be x minus 6 times x plus 5. And if we can split it up this way, the integral becomes much easier for us to complete than in its current form. So we can say 2x minus 1 over x minus 6 times x plus 5 is equal to something over x minus 6 plus something else over x plus 5. Okay. So we're just going to work on this integrand here before we actually do any integration. Right? So now we will perform this addition over here just as we would. A times x plus 5 plus b times x minus 6 all over x minus 6 times x plus 5 equals 2x minus 1 over x minus 6 x plus 5. And you can see here that the denominators are the same, so we can ignore them and just look at the numerator. So 2x minus 1 equals ax plus 5 plus b times x minus 6. Okay. Now, the thing is that's very interesting about this equation is that we have one equation with three unknowns, x, a, and b, and we're supposed to solve for two of them, a and b. Okay. But what's very helpful to know about this equation is that this equation should be true for all values of x. Okay. So it should be true for all values of x, because that's what we started with, right? All we really did here was take this expression that was in our integrand and represented it as an addition, and we know that it must be true for all values of x. So we can choose a value, choose a convenient value for x. Okay. And the way to choose it is you want to annihilate one of these two variables in the process. So my first choice is I'm going to let x equal 6. Well, what that means then is that the left side becomes 12 minus 1, which is 11. And then I have a times 6 plus 5. And then this, when I plug 6 in here, I'm going to get 0, so that goes away. So 11 is equal to a times 11. So a equals 1. Okay. Now I can take this number, 1, and plug it back in here and try to solve for b. But there's yet a better way to do this. We can just let x, we can do this process again, but choose another convenient value. So in this case, let x equals negative 5. Well, if x is equal to negative 5, the left-hand side is negative 10 minus 1 is negative 11. Okay. And the right-hand side, the a goes away, and now I have b times negative 5 minus 6. So negative 11 is equal to b times negative 11. So that means b in this case also happens, no, excuse me, I'm writing off the screen there. In this case, b is also equal to 1. Okay, so the original integral that I have, 2x minus 1 over x squared minus 30, is really equal to 1 over x plus 6 plus 1 over, sorry, this is minus 6, plus 1 over x plus 5. Okay, so this integrand that we started working with is really equal to this expression. And I can show you now why this is much simpler to work with. So now we can represent it as two separate integrals, 1 over x minus 6 dx plus 1 over x plus 5 dx, which is equal to the natural log of x minus 6 plus the natural log of x plus 5 plus a constant. And that is our final answer. So you can see from the beginning what we were working with is this expression, which uses which is pretty complicated. You want to try substitution, maybe you may even try integration by parts, but it really doesn't get the job done. Or maybe it does, but it's much more complicated. Now, this integral has that unique feature of having a easily factorable denominator, and so we're able to just apply some algebra techniques to convert it to this expression, which is much simpler, and from then on it's really easy to integrate. Okay, so this is not really related to integration by parts, but it's fits within the category of advanced integration techniques. And really the key to all of this is knowing when to use which integration method. So be sure to think about that in each of the problems that you're solving. Thank you for watching. As always, ask if you need help. Have a wonderful day.